synchronous motor is a nothing but doubly excited machine. Okay, synchronous motor is a nothing but doubly excited machine. Here we have to apply two types of excitations. One is AC and another one is DC. Okay, so synchronous motor will be consisting of mainly two parts. One is starter part and another one is rotor part. Okay, na? So here starter part is mainly consisting of armature winding. So whenever we have to apply an AC supply, only we have to apply in starter side. Next part is rotor part. Here rotor part we have to apply in only DC supply. So this is the main important point to we have to call a doubly excited machine. So synchronous machine is a nothing but doubly excited machine. The first one is the starter is consisting of armature winding and rotor is consisting of field winding. Rotor we have to apply in DC supply and starter we have to apply in AC supply. Under starting condition, without damper winding in rotor, the synchronous motor does not rotate with itself. It does not rotate itself. Okay, at the time of starting, without damper winding in rotor side, it cannot be rotate itself.
Why?
Because at the starting condition, starter flux and rotor flux both are not uniform torque. Non-uniform torque will be developed on both starter and rotor side. So that is the main reason to does not rotate itself. It is not self-starting machine at the time of start.
Induction motor, self-starting motor, sir.
Yeah. Induction motor is must and should be a self-starting machine because of we have to provide an AC supply on starter side. So according to induction principle, the magnetic flux will be linked upon the rotor side. So at the time of rotor side, the flux will be linking. According to Faraday's laws of electromagnetic induction, the flux will be cut in a conductor. The EMF will be induced in that conductor. So both flux are coincide to each other. Starter flux and rotor flux, both fluxes are coincide to each other. Then a resultant force will be experienced on a surface of the rotor. So that the time its induction motor will be freely rotate. But in a synchronous motor, it does not rotate itself because of there is no correct compensating winding, nothing but damper winding we have to provide in a rotor side. So the starter flux and rotor flux both are does not links with nothing but magnetic linking. Both
without magnetic link.
Yes, with the both starter flux and rotor flux both are not linked with at a coincide point. So this is the main reason to non-uniform torques will be produced. So that is nothing but rotor will be oscillatory motion will be occur.
Synchronous motor ki supply istam DC AC.
Synchronous motor ki we have to apply in
both supplies.
Two supplies. One is the AC supply and another one is the DC supply. AC supplies we have
starter kemo AC supply istam, rotor kemo DC supply istam.
Okay.
అక్కడ టూ మ్యాగ్నెటిజం ఫామ్ అవుతాయి. అప్పుడు మన ఈఎంఎఫ్ ప్రొడ్యూస్ అయిపోయి బ్యాక్ ఈఎంఎఫ్ ప్రొడ్యూస్ అయిపోయి మెషిన్ రొటేట్ అవుతుంది.
ఓకేనా? ఇప్పుడు
rotor is rotating but stator is stationary.
Yeah.
Yes or no? Nagesh?
Yeah, it is the main important point. And also, if in case we have to provide in damper winding in rotor side, so under a starting condition we have to apply an AC supply in starter side. So under starting condition, the synchronous motor will be acts as an induction motor because of we have to provide an damper winding in rotor side. So that position, synchronous motor will be act as like a induction motor. If the motor will be rotated at a rated speed, so that time we have to apply in DC excitation across the rotor side. Okay, now across the rotor side we have to apply in DC excitation. That's time according to Lenz's law, the cause of opposition force will be experience that damper winding. So the damper winding will be easily disconnected through the rotor circuit. So the synchronous motor will be runs at a synchronous speed. Okay, now the rotor will be rotated at a synchronous speed. So irrespective of load, the motor will be rotated at synchronous speed. అంటే లోడ్తో సంబంధం లేకుండానే లోడ్తో అసలు సంబంధం లేకుండా కాన్స్టెంట్ స్పీడ్తో రొటేట్ అవుద్ది సింక్రనస్ మోటార్ అనేది. ఇర్రెస్పెక్ట్ ఆఫ్ లోడ్ అనేది ఎందుకంటే ఇర్రెస్పెక్ట్ అంటే లోడ్తో సంబంధం లేకుండా సింక్రనస్ మోటార్ అనేది సింక్రనస్ స్పీడ్తో రొటేట్ అవుద్ది ఎన్న స్పీడ్తో. సో దిస్ ఈస్ ద ఓవరాల్ వ్యూ ఆఫ్ ది synchronous motor. So here number of phasor diagrams are included in lagging power factor, leading power factor, unity power factor, nothing but we have to vary the excitation, rotor excitation, DC excitation we have to vary it. That time it will be the starter side power factor will be easily changed, nothing but changes in different types of excitations, normal excitation, under excitation, over excitation. Over excitation means EB is greater than V. Normal excitation means EB is equal to V. Under excitation means EB is less than V. Okay na? So that we have to improve in power factor in transmission lines or improve in power factor in substations lines. We have to easily the synchronous condenser, nothing but the synchronous motor will be operated at a no load with over excitation. So that time the synchronous motor will be acts like a synchronous condenser. So those synchronous condenser will be connected across in transmission line network, either substation network. We have to in industries so many number of inductive loads we have to use, like induction motors, fans, transformers. Those are completely windings are inductive nature. So inductive nature వల్ల ఏమవుద్ది lagging power factor will be అక్కడ those completely lines, those transmission line across transmission lines and also across equipments completely lagging nature will be occur because of we have to use in completely inductive nature winding. అంటే మొత్తం వైండింగ్ మొత్తం చూడతాం కదా, చూడడం వల్ల ఏమవుతుంది ఒక టైప్ ఆఫ్ ఇండక్టర్ కింద ఫామ్ అవుతుంది. ఇండక్టర్ కింద ఫామ్ అవుతుంది అంటే ఇండక్టర్ వల్ల మనకు వచ్చే ఫ్లక్స్ అనేది అంతా లాగింగ్ గానే ఉంటుంది. ఓకేనా? So the lagging power factor will be compulsory, we have to overcome by using synchronous condenser. So those synchronous condenser will be connected across in the network. So we have to change the excitation. EB is greater than V, that is nothing but over excitation. EB is greater than V, we have to improve the excitation. That thus time the lagging power factor will be have to easily reduce, we have to improve the power factor. So this is the overall view of the synchronous motor.
Thank you, Nagesh. Are you understand fully?
Yes.
Okay.